Hello, today we are going to talk about how to create useful crash dumps, stack traces, backtraces in Fedora 37 for reporting to the KDE bug tracker. So the KDE bug tracker is this website, https://bugs.kde.org. When you want to report a bug in here, it's always a good thing to have the correct stack trace or backtrace attached, not attached, but part of the bug report. Okay, so it says the description of the bug in Bugzilla should, in here in bugs.kd.org, should contain more than application X crashed. It's really useful to have a description of how to reproduce the crash and the backtrace, the stack trace thing. What you want to do is you want your bug report to be actionable by a developer. So I am a KDE developer. I am looking at the bug report that you have just created. Is this actionable by me? Can I reproduce it on any virtual machine? Can I reproduce it on my hardware machine? What are the steps required in order to reproduce the issue? And the backtrace is really important. The precise description, so the description can be something like, here are the steps, I tried them on my hardware machine, I could reproduce the issue, I tried them on a virtual machine which was created like this and like that with this distribution using this ISO, and I could reproduce it. Or if you can't reproduce it in a virtual machine, then say so. I tried to reproduce it with a very similar virtual machine with the same distribution that I have on my hardware machine. I can reproduce it on my hardware machine. I cannot reproduce it on my virtual machine. So maybe it's a hardware enablement issue, something with GPU drivers, something with my hardware, things that don't exist in virtual machines. Okay, so now we're looking at the backtrace. So it says backtraces are essential for the people that report the issue. Maybe they're not important, but for developers are really important because, again, developers want to see bug reports that are actionable by them. I am a developer, I have 2 hours and I want to fix one issue. Let's look at one random issue in Bugzilla, in bugs.kd.org. Can I reproduce this thing? Is this actionable for me or not? Most of the issues are not reproducible. You try once using the described steps in how to reproduce the issue and you can't reproduce the issue. Why? Because you're on different hardware, you're on a virtual machine, different distribution. It's 4 years after the bug was reported. And most issues probably don't contain a correct backtrace. Backtraces make bug reports way more actionable. Even if I cannot reproduce the issue, if I see the backtrace, I have like 50% chances of fixing the issue. Or I can determine that the issue was already fixed and you should wait for KDE release version X. Okay. So the problem is that by default, in most Linux distributions, you can't create good backtraces by default. So you have to do additional steps and then you try to capture the stack trace, the backtrace. So the steps would be like this. Enable good backtraces on your Linux distro. Run the executable in GDB, which is the debugger. 3 reproduce the issue. Or tell GDB to collect the backtrace. And so we want 4 steps. We do whatever is specific for our Linux distribution such that GDB can create good backtraces. Then we start our executable using the GDB debugger. GDB debugger. Then we reproduce the issue. We make the application crash. And then we tell GDB to collect the backtrace. Okay. So this step is always needed, no matter what type of issue you have. And the rest of the steps are if one KDE app executable crashes. Sometimes it's not easy to find out what executable has crashed, but sometimes it's really possible to determine what application, what executable has crashed. So we will go through the easiest scenario possible, which is, let's pretend that the KDE calculator, kcalc, has crashed, and we're going to do these 3 steps. Okay. But first we need to enable good backtraces in your Linux distribution. In my case, it's Fedora 37. Okay. And Fedora 37 does have debuginfod by default. Okay. So debuginfod means that although the RPM packages that come installed, so I installed Fedora 37, the KDE Plasma desktop spin, and that meant that a ton of thousands of RPM packages were installed on my machine. I'm running it in a virtual machine right now. But those RPM files do not contain debug symbols. So we need to get debug symbols from somewhere. Where do we get them from? We're going to use GDB, which is going to use debuginfod, which is going to download the debug symbols needed, just the debug symbols that are needed for my application, kcalc in this example. And then those will be available to me on my system, so I will be able to create a good backtrace. Okay, so there's an intermediary between GDB, which is a debugger, and a special server that the Fedora project has, which is a server that is HTTPS and serves debug symbol packages that are needed. Okay, so GDB tells debuginfod, give me the debug symbols for the following SO files, for the following libraries. Debuginfod downloads those debug symbols, puts them in the correct place, which is probably in the local directory, in the home directory of the local the current user. So this is the cache. ~/.cache/debuginfod_client. So let's look at all of these. First, how does it look if we go the 3 steps and we skip the first, which is enable good backtraces? So let's start kcalc. This is it. This is the simple desktop calculator from the KDE project. Let's open a console terminal where we're going to, let's open two. In one, we're going to run kcalc using GDB. So we're going to do the step 2, which is GDB kcalc. And now it automatically tries to do the first step, which is enable correctly debuginfod for good backtraces. And I should answer yes to enable debuginfod, but I'm going to answer no to show you how bad backtraces look like. Go no. And now I need to tell it to start running the debugger over the process kcalc. For that we go run. Okay, so now the application works. We're going to crash the application. Okay, we're going to say get me the process ID of kcalc. And the PID process ID of PID of kcalc is 5169. And then we're going to send it the SIG-SEG signal. Double click, middle click, enter. And it says that the process kcalc has received the signal SIG-SEG, which means segmentation fault. So the application kcalc is about to crash, but we're inside the debugger GDB, and GDB has caught the moment where the crash starts. Okay, how we're going to do this? I'm going to go to Fedora, and in there it says stack traces. And it tells me the rest of the steps. So run the executable in GDB means GDB kcalc or run, then reproducing the issue is this okay, and the last step is to collect using a GDB. So for that, we're going to say this thing. So we're telling GDB to, or let's move this thing at step 2. Or not in here. Okay, so we tell it from this moment on, whatever GDB writes to the terminal, standard output and standard error, should also be written to the file ~/backtrace, which is a file in my home directory, .log. I say set logging on. And then I have, I'm generating the backtrace. So it says like this. This process has, I don't know, 7 threads. For each of these 7 threads, list what's the call stack at the place where the thread is stopped, where the thread is paused. And then at the place where the thread is paused, also get me the local variables. And maybe also the parameters to the functions. So we'll see. This quit could be also Control D. Okay, so we tell it to run. We've sent zigzag to the kcalc process, so the process has started to crash. All of the threads of kcalc have been stopped by GDB, the debugger, in here. And then it gave us the prompt GDB, where we can put the next of the commands, which are these. Doesn't work like that. Okay. So you need to paste them one by one. Okay. And in here it says so when the prompt says type red for more, Q to quit, C to continue without paging, we should write answer C. So C, press and enter. And then it shows us all of the threads, which are thread 1, thread 2, thread 3, so 3 threads. And there's some parts of the call stack. We can see main on thread 1, which is the most important thread. Says main, which is the entry point to the executable kcalc. Then qcore application exec. This is the main loop for Qt GUI applications. And then the GUI main loop uses glib, the GTK library. And then that goes poll, which goes into kernel space probably. So we have some parts of the stack trace of the call stack. It's not nothing. What we see here is really valuable. But we could do better. Just says that the application was waiting for the user to do something. All of the 3 threads go end with poll, so have on top poll. And the user, instead of performing action, clicking on a button or minimizing, maximizing the application, instead we gave it the zigzag signal from the command line. Okay. And then we disable logging, paste, and the last thing, we quit. Quit anyway, yes. And it has already killed the process 5169. GDB has killed the process kcalc. The process was crashing. GDB has stopped the crash at the exact moment where the crash started. And then when we go quit in GDB, it immediately kills the process. kcalc doesn't wait for it to finish crashing. Okay. The next thing to do is to make sure we create good backtraces. So some new Linux distributions don't need much at step 1 because they use debuginfod, and it's enough for you to let GDB use debuginfod. So this is also the case for Fedora. So we start kcalc using the debugger GDB, and this is step 1. So it asks if we want to enable debuginfod for this session. We answer Y. Okay, so we write Y and then enter. So it says that debuginfod has been enabled, and it says that I can continue entering Y and pressing enter each time I start GDB, or I could edit the .gdb init file from my home directory, so ~/.gdb init, and put this line at the end of the file on a separate line. So set debuginfod enabled on. Okay. So let's run the rest of the steps. We go run. It takes a while to start kcalc because it's going to download all of the debug info packages from the Fedora HTTPS web server. And this can take tens of minutes depending on the speed of your internet connection. But sometimes, in my experience, this thing doesn't really work. So let's demonstrate if it works or not. How do we do that? Let's start GDB again, Control D, Control C. So it says canceling download of separate debug info for a library. And now we Control D to exit. Okay, let's open it again. Again, yes. Run. And this time it actually does things. So if GDB just waits for debuginfod forever, doesn't say anything, maybe you need to close GDB and restart from scratch. Okay, so all of the debug symbols have been downloaded previously. And now we're at step this. We can kill kcalc or send it the zigzag signal. Okay, so now it says a totally different thing. This part did not exist previously. So this is Paul from from the GNU C library, which is glibc. But this time we have a better name for the function. We also have the source code file where the function is implemented, so a C file or a CPP file, files with extension .c or .cpp, not files with extension h, where the symbols are defined, so not where the definition of the symbol exists, but the implementation of the symbols exist. And then it says at line 29. And it says that it has 3 parameters named fds with this value, which is probably a pointer, file descriptor, and fds how many file descriptors, and then timeout, which is -1, which is probably infinite. Okay. And now, since kcalc has crashed, we have reproduced the issue, we continue with the rest of the steps. So here I'm going to use a different file name, backtrace underscore good dot log, set logging on, thread apply all, beautiful. Okay, so it has created the correct and good stack trace. It has paged, so it has displayed just the first page. We get the prompt type red for more, Q to quit, C to continue without paging, which is this thing. We go C, enter. It wrote all of the core stack to both the standard output, the terminal, and to the log file. And now we can stop GDB. So this is the name of the file in my home directory, where whatever was printed on the terminal was also saved to the file. Okay. So now let's look at the 2 files. Okay, so there's backtrace, which looks like this. How do we change the language? Highlighting. Anything is better than nothing. Okay, so it says that kcalc has 7 threads, starting from 1, ending with thread 7. So this is the bad stack trace. It says the name of the file, the executable, which is kcalc, then the call stack. So could be correct. It's the name of a function that's exported from a SO file. So from libc.so.6, which is the GNU C library, is exported this function, Paul. From the GTK glib is exported gmain const iterate const prop. So the call stack is incomplete, contains just the symbols that exit through the SO files, not the symbols that are interior inside of the SO file. But again, better, way better than nothing. Way better than nothing. We know there's 7 threads. We know which SO files are loaded in the memory. Okay. And it complains each time that no symbol table info available, like many times. Okay, so for each thread number, execute binary, and then for each symbol that's exported from an SO file or from an executable, it says the name of the executable and the name of the symbol that's exported. So it doesn't know which parameters were used to call this function, doesn't know the functions that are between poll and gmain context iterate, doesn't know the values of the local variables in this function. Whereas if we look at the better one, which is backtrace good, okay, so this time we have 3 threads with a better backtrace. And let's look side by side. These two, how can we do this? Okay, so thread 1. Okay. This thread, calc, correct. And then for 0, instead of just a SO file, it says the name of a C or CPP file, so the name of a translation unit for the C or C++ programming language. These files do not exist on my hardware, on my local machine. These files exist on the machine where the RPM files were built, where the Linux distribution has built these packages. Okay, and it says that the function has 3 parameters. So this poll is in fact this GI poll. This is the way it's named in the C file. And it doesn't say how many parameters or names or values, where in here we see that this function was called with 3 parameters. These are the names and these are the values, 2 and -1. So again, we have name of file, we have line number, where this symbol is implemented in the translation unit. Then it says in this function, at the moment that the crash occurs, there were 3 local variables defined, which are these 3 with these 3 values. And then the next, so this GI poll function was called by gmain context poll. Gmain context. So this doesn't even appear in here. So it should be in here. Because gmain const iterate .const prop is this guy. So this is the name of the function exported from this SO file, whereas this file is in fact defined in this translation unit at this line. It's implemented, not defined. Okay. Again, the function was called with 4 parameters. It's kind of a method because it has self or this as parameter. There's a pointer named context, and there's block 1, dispatch 1, and this self, which is a pointer to the current object. And when the crash occurred, look, there were 7 local variables with these names and these values. Okay, in here is this call gmain context poll, but this is not exported through libglib to SO. It's just exists inside of the source code of glib, the GTK library. In this file on this line, and it has these local variables. So a huge difference in quality between this, let's say between this and this, which are equivalent. So these 4 lines, where one does not contain information, gets expanded to 20 lines if the stack trace is good. So again, this is on the right hand side we have a good stack trace, on the left hand side we have a bad stack trace. This is complete, the good one, and the bad one is not complete. This type of stack trace we want to see in bugs.kd.org. Okay, so a quick recap. In Fedora 37, there's not much you need to do in order to get good backtraces. Just when you start GDB, at this prompt, the default value is N, no, to not enable debuginfod, and you say Y, so to enable debuginfod. And then you wait. But wait if you see progress. So if it says downloading debugging symbols for glibc.so, okay, you wait for the progress to finish. But if it just doesn't say anything, just stays there for tens of minutes with no activity in top, no activity in the network transfer during that time, then yeah, restart GDB from scratch. Okay, so that was the simple scenario when just one executable crashes. We know exactly which executable is, and the executable doesn't have any command line parameters. We start it under GDB, and we reproduce the issue, and then we collect the backtrace. Okay, let's see if we can do more, like when we don't know which executable has crashed, or when the executable has command line parameters. So I'm going to start 2 terminals, and I'm going to start kcalc from the command line, just as an example application, could have been anything else. Then I'm going to crash it using the same procedure. I copy the process ID, PID. I kill it. And then it says that kcalc has started kcrash, which is application from KDE for crash reporting, crash handling. So that has shown up in the system tray and has showed a notification pop-up balloon. that notification pop-up balloon has closed, and we still have Dr. Conky in the system tray. So I click on it, and it says that KCalc was closed unexpectedly. You can help us improve the KDE software by reporting this error. It takes us to the correct place, which is a huge, and a wiki page that contains a ton of information to digest. It's not just that the page is long, but also you need to consider many things when you understand correctly this entire wiki web page. Okay, so it says the correct process name, the correct process ID, the correct reason, signal segmentation fault 11, the correct time, and then we say report bug, and it says that we must agree to be contacted. Okay, then it says, do you remember what you were doing? Yes. So there's some information you need to give here, otherwise you will not be able to use this crash handler to report the issue. It says not sufficiently useful. The information you can provide is not considered helpful enough in this case. If you can't think of any more information, you can close the bug report dialog. Close. And let's put more information in here. So it says, do you remember? Yes. Every time what I was doing at the time when the application KCalc crashed. Yeah, I know exactly what I was doing. I was doing kill space -6 save space the PID of crash of KCalc. I go next, and it says it wants to fetch a good backtrace. So it says in order to generate a good backtrace on Fedora 37, we need to install the needed packages, which is this list. No, we don't need to install any package. We need just to make sure that debuginfod is enabled for my user for my GDB. We go close, so this is obsolete information, what's coming after the semicolon, so install the needed packages. Please read how to create useful crash reports. Let's see what this page is. It's the page that we were reading, and we went to Arch, over to Fedora. Okay. Again, this information is for Fedora previous versions than 37, where debuginfod was not available by default. Okay. But it's useful, this wiki page, such that we know that we don't want a backtrace, we want a good backtrace. It says in here why backtraces are really important. And now we go show backtrace content advanced, and it shows the bad stack trace, because in here we have .so file instead of having .c files. In here we have functions which are exported from SO files, not functions as they are defined in .c or .cpp files. Between this pair of round brackets parentheses, there's no list of parameters that were with which this function was called. In here there are 3 parameters, in here there are 4. And there are no local variables. Why? Well, because it tells GDB, please create a stack dump, a backtrace, but it doesn't tell it create a backtrace and enable debuginfod at the same time. So we press reload, and we see for a millisecond what really happens. So it says DGDB supports auto-downloading debuginfo from the following URLs. Enable debuginfod for this session. Yes, default no. Answer no. Input not from terminal. Debuginfod has been disabled. To make this setting permanent, add set debuginfod enabled off to GDB init. Okay, so let's try to edit this file, make debuginfod enabled by default, and maybe this way Kcrash will collect a good backtrace using GDB. So Kate / dot GDB init. GDB init. Okay, so this file is empty. Where can we see this information better? In here. So we can set the environment variable, debuginfod, progress, verbose, URLs, if we want in etc profile D or in etc profile, and then we reboot the machine, and that's really good. Or in the /.gdb init, we can have this thing. Control V, and this should be on. Make sure you have a trailing new line, Control S. And now let's show backtrace content advanced again. Show, not reload. Okay. So it does not really matter what I set, because GDB will refuse to read .gdb init. Let me crash kcalc again, maybe. This is the way to do it. Okay. Report bug. Report bug. I agree to be contacted. Yes. Every time I know what I was doing. Show backtrace content advanced. And it shows the bad stack trace. Input not from terminal. Answered no. Okay, I will look into this issue and see if we can fix it. So for new versions of Fedora that have debuginfod installed by default, we should not have this part of the message. So install the needed packages, list of packages, and click the reload button. And then reload should answer yes, or not answer anything, just let GDB do its thing. So GDB stops asking again if the configuration file already exists. So let me set this environment variable, and maybe that's enough. Okay, how do we do this? So we need a variable in etc profile D. cd/etc. So we could add it in here, or we could add it really cleanly in /etc/profile_d. Okay, what's in here? We need a debuginfod. Debuginfod dot something. F4, F3. If not exists debuginfod URLs, then prefix /usr debuginfod URLs cat /etc/debuginfod URLs. I can see it being set correctly in here. So debuginfod URLs is actually set. Okay, I'll research into it. So GDB, if I started just GDB, it looks at ~/.gdbinfo and does the right thing, which is always use debuginfod. But when kcrash starts GDB, then it tells GDB to forget its configuration or something such that GDB doesn't use the configuration in ~./gdbinit. Okay, so it seems that everything was already implemented in this bug 454063. So kcrash was calling GDB with ---- batch parameter, and that automatically wrote an uppercase N at the when GDB asks itself if debuginfod should be enabled. So GDB itself replied with an uppercase no, so that's where we're at. And then this issue is fixed by Harald S, where if a Linux distribution has GDB 12, which is the case for Fedora 37, then there's a CMake option with GDB 12, probably for Dr. Conky. Okay, and then there should be a button where it retraces with debuginfod enabled. Okay. The only problem with this fix is that it was made 1 month ago in October 2022 and probably did not make it into Fedora 37, but will be available in Fedora 38. Okay, so that's it. Hopefully you can reproduce the issue with just one executable, then you know how to run that executable in GDB. If a more complex scenario happens, but you have the Dr. Conky kcrash system tray prompt, and you have Fedora newer than 37, so 38 and up, then the correct backtrace will be, good backtrace will be generated using GDB with the option set debuginfod enabled on. So that was it. Thank you.